All right, y'all, let's find some limits graphically. All right, I want to find some limits graphically. Now, I've developed my own graph. So in the next screen, you'll see a graph with some discontinuities. I have 12 questions prepared. Some of those questions may lead to other questions. So let's get started. So this notation, let's read what this is saying. This is saying, what is the limit as x approaches -3? So this is the x value that you are approaching. This symbol here, this means we're going to approach from the left side. Okay, so that is a left-sided limit. Now let's look at the notation for, say, a right-sided limit. So look at this notation. This notation is saying, what is the limit as x approaches -3? So that is the -3. That's the x value that we're trying to get as close to as possible from the right side. So this little positive symbol right here indicates the right side, okay? Now, if you don't see the left side notation or the right side notation, such as this is asking for the two-sided limit. And so what you need to know is in order for a two-sided limit to exist, the left-sided limit and the right-sided limit must be the same. They must approach the same limit value, okay? So keep that in mind. This limit as x approaches -3 of f of x can only exist if the left-sided limit and the right-sided limit are exactly the same. So let's answer these questions. So let's look very carefully. The first question is asking, what is the limit as x approaches -3 from the left side? So again, the -3 is the x value that we are trying to get as close to as possible. This negative symbol up here indicates left side, left-sided limit. So that indicates the left side. So what we want to do is find -3 on the x-axis. And we want to trace our function, so the red graph, starting from the left side of -3 and get as close to -3 as possible. So I'm going to start on the left side of -3. I'm going to trace along my red curve until I get as close to -3 as possible. Now notice what I'm saying, as close to -3 as possible. That doesn't mean I'm going to touch -3. That means I'm getting as close as possible. So think of values that are less than -3 but are very close to -3, such as -3.001 or -3.0001 or -3.00001. You get the idea? So not when x equals -3, but as x approaches -3. And so as we get as close as possible to -3 from the left side, the function value starts to approach. If you trace along, you'll notice that that limit value is 4. Okay, so now let's look at number 2. Number 2 is asking us, what is the limit as x approaches -3? So again, that's the x value that we're getting as close to as possible. But this time, we want to look from the right side. Okay, so I'm going to trace along my red curve. I'm starting on the right side of -3. So anywhere over here, I'm tracing along. We're getting as close to -3 as possible from the right side. So think of values such as -2.9, -2.99, -2.99999, as close as possible, but don't touch -3. And what you'll find is, as x values get closer to -3 from the right side, your function values will get closer to 0. So that leads to question number 3. Well, remember what this notation means. This is asking simply, what is the limit as x approaches -3? Notice there's no left side indicated or right side indicated. This is known as a two-sided limit. In order for a two-sided limit to exist, the left-sided limit and the right-sided limit must be the same. And so what we just found in problems 1 and 2, the left-sided limit as x approaches negative 3 is equal to 4. The right side of limit as x approaches negative 3 is 0. And since they are not the same, then what we would say for this limit is it does not exist. So I use DNE for does not exist. Now, number 4 is simply asking, this is not a limit. This is a function value. So what is the actual value of the function when x is equal to negative 3? So what is the function value when x is negative 3? So that's where the significance of open and closed circles comes from. So when x is actually negative 3, notice the y value is 2. So this equals 2. That represents a coordinate on this function. Number 5 is asking, what is the limit as x approaches 0 from the left side? So 0 is the y-axis. As I get closer to 0, let's change my color. From the left side, notice my function begins to decrease very, very rapidly. And so what happens here is there seems to be a vertical asymptote at x equals 0. And so as I get closer to 0 from the left side, my function value actually starts to approach negative infinity. All right, let's look at some more. Okay, so number 6 is saying, what is the limit as x approaches 0 from the right side? Well, let's do what we've been doing. Let's start on the right side of 0, and let's trace along. And notice the function starts to approach infinity. So this would be positive infinity. Okay. All right, number 7. What is the limit as x approaches positive 2 from the left side? So again, we're going to trace on the left side of positive 2. Notice the function value starts to approach 1, right? We're getting as close to 2 as possible from the left side, but we're actually not touching x equals 2. And so the limit as x approaches 2 from the left side will be 1. The limit as x approaches 2 from the right side, well, do the same thing, approach 2 from the right side, and the limit value would be 1. And so now number 9 says, what is the limit as x approaches 2 of f of x? Well, since the left side of limit and the right side of limit both equal 1, I say that the limit as x approaches 2 of f of x is equal to 1. And that's because the left side of limit and the right side of limit approach the same value. What is the function value at 2? And that's where we need the closed circle. So when x actually does equal 2, the function value there, let me do that real quick. The function value there is negative 2. All right, and like I said, some of these questions lead to other questions, such as, well, let's see here. Is this function continuous at x equals 2? Well, notice the 2-sided limit does exist, but there's a hole there. And so the function value at 2 is equal to negative 2. However, the limit as x approaches 2 is equal to 1. And so this is discontinuous. Very soon we'll create a video talking about continuity. So look for that very soon. All right, and the last 2 questions that I want to discuss is, what if I have the limit as x approaches negative infinity? So what that means is, on the function, I want to trace the function and go to negative infinity. So if I were to continue on, notice the arrow says this is going to continue on. So if I were to continue on going to negative infinity on the x-axis, my function value, because of that arrow, my function value would start to approach positive infinity. And then lastly, what's the limit as x approaches positive infinity? Well, if I trace along, as x increases, this might be a horizontal asymptote. And so as x increases to infinity, the function value begins to approach 0. All right, so I hope this video helped. Let me know if you have any questions, and I'll see you in the next one.